So this is an exciting time right now, for me as a math teacher, because, and I know it would be for Nate too, because I've armed you with all these things that you really have no clue what they're really about, right? You've learned the quadratic formula, you've learned how to compute the square, you've learned all these tools for factoring differences of two squares and factoring things with a when a is 1, a trinomial, factoring a trinomial when a is bigger than 1, you know, factoring a 4-term problem or a 4-term expression. You know how to do all these things, but we haven't pulled it together to actually see how it's useful. Well, now you know this stuff, so it's time to start using it in real life. You know, not that this is the most real life-like problem in the world, but they're fun anyway, right? And it all is based on a formula called the vertical motion model, okay? And it's quite well known. In fact, it is the quadratic equation with just different letters, all right? It's not the quadratic formula. You know the difference between the quadratic formula versus the quadratic equation. The formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a, right? But the quadratic equation is what? It's y equals ax squared. Okay, so that is your quadratic equation, right? Now, the vertical motion model uses the exact same equation, except that it replaces the a for an actual number, and it uses different variables. So it is h equals negative 16 t squared plus vt plus s. Okay? And they'll all make sense in just a second. I just wanted you to see that it's exactly the same thing as the quadratic equation. All right? Now, we're going to just define these for a second. I just want to be sure how far I can go here. So somewhere there. Okay. So H is the height. H-E-I-G-H-T, right? Doesn't look right. Oh, I'm writing lower, no wonder. Okay, height. Over time. So think about it. I've got a parabola, right? Is my parabola going to be a happy face parabola or a sad face parabola? It's a sad face parabola, right? Which sort of makes sense to me because every time I've seen an armadillo jump, he's always stopped at one point and come back down again. That makes sense to me, right? He's not likely to keep going, right? Up, right? Not likely. So to me that makes sense. It should be a, you know, sad face parabola, right? Now the height is any place along here, right? Any place along there. If I stopped, let's say I had my graph, right, where this is 0, time is 0. This is my time, and this is my height.
Should we be copying this?
My height, if you like. I'm trying to just help you understand what this is, right? So the height is at any time, and the time is in seconds, right? Seconds. At any, let's say it took 1 second, 2 seconds, 3 seconds, right? Let's say at 1 second I wanted to know what the height was. I could replace the t with 1, right? And I would have to know my v, and I'd have to know my s. And that's given in your equation. So we're going to talk about that in a second. But the height is whatever height it is at any given time, right? Makes sense, all right? So the t is the time in seconds. I'm writing in lowercase. Why am I doing this? Time in seconds. I never do this. Okay, witnessing something truly remarkable here. V. V is called vertical velocity. I really have to think to write this in lowercase. Velocity. Vertical velocity. We'll talk about that in a second. And S is the initial height. Initial height, meaning like the starting height. S for starting, right? The starting height. Oh dear, now I'm in the capitals again. Oh. Starting height, initial height, starting height. And notice that would be when t is equal to 0, right? When before the clock starts ticking, he's on the ground, right? And then he's going to jump. As soon as he started jumping, the clock started ticking, right? Right? And so that's kind of the scenario. Now, can I erase this graph for a second? We're going to start talking about what this means. The one part that I think is confusing is vertical velocity. Vertical velocity, what is velocity? Approximately, what would you think of velocity if you think of a car?
It's like the speed.
It's sort of like the speed, right? How fast something's going. Well, vertical velocity is how fast is he traveling vertically. Like if he jumps straight up and straight down, there's a vertical velocity the second he leaves the ground. Do you agree with me? Now, does that vertical velocity continue at a constant rate? Why? He's got to come back down again. What is it? What force is it that's acting upon him?
Gravity.
Gravity, right? So something's got to take care of the concept of gravity. That is your negative 16. Your A is negative 16. That is taking. That's basically equating to the force of gravity. Okay? As long as we're talking about feet, we're talking, oh wait, I should tell you this, height. And this is in feet. In feet. We're not doing meters per second, we're doing feet per second. If it were meters per second, it would be a different number here, right? But we're talking feet per second, so this is in that thing. So, when he jumps off the ground, he's going upward at a certain velocity, and then that negative 16, that gravity slows him up. And there's a point where he actually just stops in midair for a split second, and then he comes back down again, right? Right? And you would think when you graphed this that it would not be a problem. You would think that it would just be a straight line, right? You would think it would go like this. He would go up and down. But remember, it's based on time. As soon as he leaves the ground, the clock starts ticking. So suddenly, you've got to take that into consideration. So therefore,
so the graph is like time is x and height is y.
Exactly. Your time is your horizontal. And that's almost always the case. Whenever you have a graph with time, almost always it's going to be your x-axis is going to be the time. Okay? So now let's look at this. Let's start filling things in. It says a startled armadillo jumps straight into the air with an initial vertical velocity of 14 feet per second. So let's use what we got. We know height is h equals, this is our formula, negative 16 t squared plus, now what's the vertical velocity? 14 feet per second. In 1 second, if he kept going, right? If he kept going at that speed, if he didn't have gravity that's slowing him up, in a second, he would have traveled 14 feet, right? But because of gravity, it's not going to happen, right? But that's okay, because it is the initial, vertical velocity is your initial vertical velocity. I should say initial here, just so you know. It's the initial vertical velocity. So vertical velocity is 14. And then t is time. We don't know the time, do we? And then we've got plus. Now it has s. What is s again? My starting height, or his starting height. Now, it doesn't say he was on the ground, but my guess is he wasn't on a chair, right? It's just my guess, right? But I think it's pretty safe to say he was probably on the ground, right? I mean, I don't think he'd be jumping at 14 feet per second if he was in a tree, right? I sure wouldn't, right? So he'd probably be on the ground. We're going to make that assumption. So we're going to say he's on the ground. Well, where is the ground? 0. So plus 0. So technically, I don't even need that, right? I wrote it just so you can see it. So now let's see what the question is. It says, after how many seconds? What are they asking me to find? T or H? T. Find T when he lands on the ground. Now clearly, we're not asked to be finding T at time 0, right? When he's already on the ground. We're asking after he's jumped, then how much seconds will it take for him to land back on the ground? So we're looking for this point right there. What is that called? You all know it. It's a parabola, and it's what you've been finding whenever you... Yeah, you're finding the zeros, right? Look at that. Isn't that the zeros? You've got a 0 here, and you've got a 0 here. And every time you use the quadratic formula, you're finding the zeros, right? And you get 2 answers. Clearly, the one that is 0 is not the answer. The one that's big, that's positive, is going to be the answer. Does that make sense? That's what you're doing. So now we're asked to find T when H is what? Here's H. Down here, what is H? H is 0, right? We're asked to find T when H, the height, is 0. Does that make sense? So I'm going to make the height 0. So suddenly I have 0 is equal to negative 16t squared plus 14t. Now I'm not going to write the plus 0. I don't need it. It doesn't mean anything, right? Now, in a quadratic equation, what are we missing? We've got an ax squared plus bx plus c. We're missing a c, right? C is 0. When you don't have a c, they're the easiest things on the planet to solve. Can you see it? You're welcome to. I'm sorry. When you don't have a c, they're absolutely the easiest things on the planet to solve. So let's think about it. So what do you use? What's the first thing you always try for factoring? Factoring out the greatest common factor, right? So what's the greatest common factor? 2. What else? T, right? 2t. All right, let's factor it out. What would I have here? Can you see?
You would have
negative 8t plus 7, right? And this equals 0, right? I'm just going to move the 0 over there. If a times b equals 0, then either a equals 0 or b equals 0. Y'all know this, remember? You know that rule, right? If a times b equals 0, then either this equals 0, either 2t equals 0, divide by 2 t equals 0, which I already knew, or negative 8t plus 7 equals 0, right? To subtract 7, I have negative 8t is equal to negative 7, divide by negative 8, divide by negative 8. My time is, the negatives cross out, so it's just 7/8 of a second. So I know it took the armadillo just under a second, 7/8 of a second, to land back way down on the ground. Make sense?
Wait, but I'm confused. What happened to the 2t?
I solve for it, and dividing both sides by 2, I get t equals 0. That reminds me, oh yeah, that was before, that means time is 0, before the armadillo jumped, right? Remember, for this kind of a problem, there's going to be two answers, right? Because it's an upward down parabola. I mean, upside down. I mean, it's a sad face parabola. It's going to have to be two answers, right? Right? Make sense?
So, but wouldn't it be negative 7/8?
But it's, notice it was negative 8t equals negative 7. Divide by negative. You got negative divided by negative is positive.
True.
Right? So it's positive 7/8. Yeah. It would definitely be confusing if it was negative 7/8 because you can't have a negative time, right, for the armadillo jumping. Does that make sense? So we're done. So now they asked it in a question, so I would answer it in a question. I mean, they asked it in words. I would answer it in words. After how many seconds does it land on the ground? It after whatever. After 7/8 seconds. Right? I'll just do it that way. It lands on the ground. Make sense? So it's pretty straightforward. Now, if I had, can I erase this? Are you guys done copying it? I want you to see how cool this is in a second here. Hang on. I'm going to erase this. What if I said, let's say I was on the top of a big building that was, I don't know, 800 feet tall, right? And I drop a penny off the building, and I want to know how long it will take for it to hit the ground. Could I use this formula for that?
Yeah.
Let's think about it for a second. So I've got a penny. Okay, penny falls off. It doesn't get, I'm not throwing it up. Let's say I'm not going to do a vertical velocity this time. Does that make sense? I'm not throwing it up. There's not a vertical velocity. I'm just pushing it off the edge, right? It's on the roof, and I just push it off the edge. There's no vertical velocity upwards. It just immediately starts to fall, right? So let's think about that. And it's 800 feet up, 0 vertical velocity, right? And I want to know how long it will take for it to hit the ground. So I've got my h is equal to negative 16 t squared plus, now my vertical velocity is nothing, right? I'm not throwing the penny upwards, and I'm not throwing it down. I'm just letting gravity take it. Make sense? So therefore that v is 0. So really it's just 0 there. Plus, how high up am I? 800 feet. So I'm going to say 800. So really what I have is h is equal to negative 16 t squared plus 800. Right? Now, when I'm asking how long, what will t be when h is what? When it hits the ground, which is h is 0, right? Does that make sense? Makes sense, right? So I'm saying, okay, what would it be if when the height of the penny is 0, meaning it hits the ground? It's negative 16 t squared plus 800. All right, so what would I do? I don't have now, what am I missing now? I'm missing my b, right? I have an a and a c. Well, that's interesting. Those are really easy to solve. Because look, all I have to do is this. Subtract 800. Well, actually, you know what I'll do? I'll just add 16 t squared. Add 16 t squared to both sides. And then suddenly I have 16 t squared is equal to 800. Right? What would I do now? How about divide both sides by 16? Don't you think? Right? Do we have a calculator on them?
I think it's 50.
Is it? 16 times 5 is 8. You're right, I think it is. So we've got t squared equals 50. All right. Now what would I do?
Now you have to get like square each.
Yeah, well,
Kind of. You have to get rid of the squared part. You have to like do that thing.
what is that thing called again?
Oh, you square root.
Square root, yes,
Yep,
that's
there
it.
is.
So, as long as you do to the same side, to both sides, there's no problem. So suddenly we have, so we're going to come up here. That's an arrow. So we have t is equal to, what goes in front of this? I just took the square root of both sides, just like you did when you're completing the square.
Plus or minus.
Plus or minus. I've got to have a plus or minus there. The square root of 50, whatever the heck that is. I could simplify that. Should we simplify it just for fun?
Yeah, we have like 2 minutes.
It's what?
5 square root of 2.
5 square root of 2, right? 20 square root of 25 times the square root of 2, so 5 square root of 2. So we could say t is equal to plus or minus 5 square root of 2 if we wanted to. We could, either one of those is correct. Now, which one does not make sense though? The plus or the minus? Minus, that makes sense. You can't have a negative time, right? Therefore, really, the answer is the square root of 50 or 5 square root of 2, right? So I could take out my calculator, which I don't have. Anybody have a calculator on them? Type in 50 and square root.
It's 7.071067.
7 point what?
0710678.
Okay, that's plenty. Okay, and this is in seconds. It took a little over 7 seconds for that penny to hit the ground. Isn't that cool? I mean, you actually have a model now that allows you to take into consideration gravity, takes into consideration vertical velocity, initial vertical velocity. Now, what if I took the penny and I threw it down? Would that be different than if I just pushed it off the edge?
Velocity, right?
What?
Is that negative vertical velocity?
What would it be? It would be vertical
It'd
velocity.
be negative.
It would be a negative, right? Instead of a positive vertical velocity going upward, it's going down at a faster rate initially, right? And then gravity is going to take over, and it's just going to go faster, right? Yeah.
Carrie, like, well, they say like, you know that myth if you push a penny off the Empire State Building on hit someone because of air going up, it like changes the time. So does that account?
Also,
This does not account for the air.
also
Air
at a
friction.
certain
Yeah, good
point
question.
it would stop
I
flowing.
knew somebody would ask that question.
It would stop. It reach a maximum point in which it can fall faster. Is there the
Yes, I think you're right.
Well, no, they're
You're right. All right, good guys. So homework.